everyone. Hello, hi everyone. Okay, thanks for attending this webinar. Today we are going to present a new component that we have developed recently in OpenNebula. My name is Marco Mancini with my colleague Daniele Vincolla. We are going to introduce about this new component that we released recently. We released a first version, so it's already available. We are going to show also how it works. And so you can start to try, and then let's see how this also will evolve in the future. Let me give a brief introduction about OpenNebula. So OpenNebula System is a company that is based on Madrid. We developed this product, OpenNebula, that is the first open source infrastructure as a service solution that was created more than 15 years ago. OpenNebula was born as a solution for private cloud computing mainly, but today has evolved as an open source, easy to use enterprise platform that you can use for on-premise private cloud computing, hybrid, also edge cloud computing. So we support different virtualization. So we support virtual machine with KVM, LXC system containers, and also you can create Kubernetes clusters, and we support different type of infrastructure, as I said, so from on-premise to cloud providers, and then also multi-cloud and hybrid strategies. So what is the webinar today? Let me go through the agenda. So first of all, I will introduce what is the MCP, the Model Context Protocol. Then my colleague Daniele will proceed and talk about how we have implemented and designed the MCP server for OpenNebula. Then we will proceed with a live demo to show how you can use the MCP with OpenNebula. And finally, we will tell you about what is the roadmap, how we also, since we released this recently, if you want to try and also contribute to how you can also contribute to do this tool that we have developed. Okay, so let me start with the MCP. Okay, so the MCP Model Context Protocol was released almost 1 year ago by Anthropic, the company behind Claude. So what is the Model Context Protocol? It's a standard that allow you to connect AI assistant, so LLM, to tools, to systems. So if you have some database or a system, a cloud management platform like OpenNebula or a repository like GitHub, so any system you can think that has an API, if you enhance with this MCP protocol, the idea here is that the LLM will have a context about the tools that can use to interact with the system. So this practically increase the accuracy of the LLM, reduce the number of the hallucination, but also you control how the LLM can interact with the system, and also which action can be performed on the system. So the main thing here is that thanks to this, the LLM practically can interface with any type of API, for example, tools, database, and as I said, in this case also OpenNebula, because we have implemented an MCP server for OpenNebula. You can build the MCP server in order to be also secure, safe, because, for example, you can allow only read operation. Clearly, when you enable also write operation that can, let's say, modify the system, clearly one has to be careful about which kind of operation an LLM can execute practically, so which action. The advantage of this MCP is that now we are getting closer to what it is like an index-based system, because you can start with the natural language. So you can express what is your intent using natural language. And then this intent is translated somehow in different actions that are action against the system that you have that LLM can use, okay? According to thanks to the MCP server. So let me go through how it usually works. So practically the user make a request to the client. So you have to use some MCP client. Then Daniele will show a demo using, for example, Word, that is an AI-enhanced terminal. And you express this using natural language. Then the client, what he does is to request, first of all, which are the tools that are available from the MCP server, and then use these tools as a context with the as a context for the user request, and present this to the LLM. And now the LLM can reply according to the user query, which is the tool that can be used in order to fulfill the request by the user. For example, let's say if I use natural language, create a VM, a virtual machine based on some operating system and so on. And then it will reply with a tool that it can be used by the MC, that can be used by the client to interact with the MCP server. So it will pass to the MCP server the tool with the parameters that has been set by the LLM. And now the MCP server can apply this action, because it's the MCP server that will interact with the OpenNebula. Taking into account that the MCP server is something local to the laptop that or to the desktop that the user use, is not a remote service. Usually you can install and use locally. And then when interact with the system, the reply will be used by the client to interact again with the LLM that will interpret the response of the system, and then finally the MCP client will respond to the user. That's how the MCP works. So this is to give you an idea about the MCP protocol and also how it works. But I think now with Daniele, he will proceed in telling you about the OpenNebula MCP server, and also will proceed with the demo, so you can see in action how it works. Okay, Daniele, you can.
Hello, everyone. I'm Daniele, and I'm in the team of Marco, and together with him, we have developed this MCP server. So let's start by introducing what the OpenNebula MCP server is a bit more in details, and why it's important and how it can help you. Okay, so as Marco said previously, MCP server is very important because it allows us to have an intent-based system, right? So we can translate natural language into cloud operations, specifically in this case because we are talking about OpenNebula, right? So from instruction to intent, this means that AI can interpret natural language and translate your objective directly into OpenNebula commands and into operational logic, okay, executable operational logic. So if, for example, you take a look at the picture on the right, you can see that without using the MCP server, you have to run the command, for example, 1VM shows 724 if you want to get some more information about a specific VM. But after the implementation of the MCP server, if you use it, what you can do is just write in your favorite MCP client, give me more details about the VM. So you just specify what you want, and then the MCP server will automatically interact with different LLM providers. You can select, for example, ChatGPT or Cloud or Gemini, whatever you want, because the MCP is a protocol that standardize the communication, right, with different LLM providers. You specify the how, and then the MCP server will automatically do all the steps. Now, here in the picture, we put something very simple, but show give me more details about a VM. But of course, these LLM are very powerful, no? So the MCP server, what enable you to do is also to execute complex end-to-end workflow from a single command. So it's not just executing a command, but it's creating a plan that at the end, once executed, will accomplish what you ask to the MCP server to accomplish. Okay, why this is important? Because typically when you want to manage a cloud node, you need to do a lot of operations. Sometimes you need to develop scripts, custom scripts, and sometimes this could be like a bit cumbersome, a bit complicated, right? So thanks to this MCP server, you can, for most of the times, you can avoid to write manual scripts, and of course, also maintaining that, right? Then another important feature, another important advantages of using the MCP server is that it is conversational, right? So this means that you don't need to interact with complex interfaces, with complex command line interfaces, right? So this means that literally you just write what you want, and this makes the cloud management intuitive and really accessible to everyone, especially to people that, of course, have started using OpenNebula recently, right? So they don't know a lot about the command, and sometimes we all forget, right, the command. So it's good to have a tool that will do everything for us. So please, Mark, if you can change the slide. So given that we have recently released this first implementation, I think it's very important to underline what are the core principles at the base of our implementation, how we have developed the MCP server. First of all, it's secure by design. So what does it mean? Let's start from the beginning. We know that the LLM models are becoming very smart, very intelligent, and so on, but still there are some chances that they hallucinated. What this means? This means that you tell them to do something and they do something else. Of course, this could not be a problem in some cases, but when we are talking about cloud management using LLMs, this becomes a very huge problem, right? Because they could do something that they are not intended to do, right? For example, reboot a virtual machine, or turn it off a virtual machine, or installing things that it should not install. So what we have done in order to remove this risk is being able to run the MCP server in read mode only. What does this mean? This means that the MCP server and the LLM will not automatically execute any command that could change the status of your cloud. So for example, if you want to have a comprehensive overview of your cloud, of your virtual machine, or your host, or your network, and so on, this is allowed. But if you want to execute, for example, a specific command within a VM, or if you want to change the status of a virtual machine, so for example, you want to reboot a virtual machine or something like this, you cannot do this in this mode. Okay. Extensible by nature. What does it mean? This means that the MCP server has been built on an open standard, of course, and it's very easy, and then later I will show how to do it, to improve this tool and to adapt to your own use cases. So you don't need to know a lot about coding, but you can just enter in the code base of our MCP server. You can just literally change some markdown files that are like instructing the MCP server on what it can and what it cannot do. You can write your own instruction if needed, and then you will automatically have the MCP server adapted to your cases. And then, of course, it focused on OpenNebula, so it's deeply integrated with the OpenNebula ecosystem in order to have, in order to maximize the effectiveness of this. And we also will talk later about what the MCP server can practically do. So now, please, if my colleague can proceed. Okay, so now it's time to just show you some use cases that we have prepared in order to allow you to understand how powerful this tool is and how you can also use it based on your own use cases. So now I will share my my terminal. Okay, perfect. So first of all, I'm using Warp. Okay, what is Warp? Warp is a command line interface, but it's very important for me to highlight that you can use different MCP clients. So for example, if you prefer Visual Studio Code, you can use it. The important thing is that it should be integrated with the MCP server. So I'm using Word, but you can use literally whatever you want, as long as it's integrated with MCP server. But something that I really want to underline are the settings. Why? Because the settings, in order to make your MCP client, in this case Word, compatible with and able to execute the MCP server, are more or less the same regardless of the client that you are using. Okay, so in this case, typically the structure of the configuration is always the same. So you have the in this case the name of the MCP server. I call it OpenNebula MCP Server, but it's not so important. You can call it how you want, or how you prefer. Then in this case, in order to run the MCP server, we are using UV in order to create the virtual environment to manage all the dependencies. And so what this means is that the Word, in my case, but whatever MCP client, will automatically run this command every time, and will be able, thanks to these commands, to interact with our MCP server. So it will use this virtual env in the one MCP repository, in the repository of the MCP server. Of course, you can find all the instruction on how to install the dependencies in the repository on GitHub. Now, let's go a bit on some very important arguments that you can also pass to the main code of the MCP server, that are the allow write. Okay, this is what I was explaining before, right? So if you pass this argument, this means that the MCP server is allowed to execute commands automatically that can change the status of your cloud. So for example, it can run, execute commands within a virtual machine, it can stop, start services, and so on. The log level is quite self-explanatory. So if you put debug, of course, you can put debug, info, and so on. You will get a different level of logs. Okay. Given that, as I said, feel free to use whatever MCP client is the best choice for you, and you can find more information about how to install all dependencies for MCP server in the official repo of GitHub. Now, let's imagine, for example, a use case, where you want to have an overview of the host in your clusters, of the virtual machine that are running, and all about some information about the networks, the virtual networks. So what you should do, if you don't have the MCP server, of course, is the one VM list. Okay, so you can see here the VM list, or you can also run, if you want to have more information about the host, one host. If you want to have some more details about the host, you need to run, for example, one host show, and then you need to pass the ID of the host. Okay. And you can see all of this information. The same, of course, also for the network. Now, what's the problem here? The problem is that, first of all, you need to remember all these commands. Okay, these ones are quite easy, but there are some others that are not so easy. And then, as you can see, it's quite hard to read the output, right? I mean, there are a lot of information in this case. So imagine that I'm just interested, I don't know, in knowing the CPU total, okay? I should read all of these, and then I need to find this information. Then I can say, okay, the CPU total is this one. But imagine another case where we have the MCP server installed. What we can do is just write, for example, something like show me the status of all host, including only running VMs and all virtual networks. Okay, let's see what happens. Okay, so what's happening here? First of all, you can see that here my MCP client, so Word, has been able to correctly identify the MCP tool. As my colleague previously said, this MCP server is exposing different MCP tools that can be understood by the LLM, and the LLM will be able also to understand which parameters to use and so on in order to reach the goal that you want him to reach. So as you can see, I just ask what I want. not how, okay? And it give me this very beautiful and well formatted and simple to read also information about the host status, for example, the host status, the running virtual machines. We have all the information about, for example, the CPU, the name, the ID, and all the information about the virtual networks. Now, of course, we can ask different things like, hey, put this information in a tabular format, in a JSON format, or just you can just filter by the ID, by the CPU available, and so on. This is just to show you how easy it is, literally, have all this information thanks to the MCP server. And remember that I haven't executed any command, okay? So I didn't execute any one host show, any one host list, any one VM list, and so on. Now, let's try, for example, another use case. Let's imagine that we want to instantiate a VM, an Ubuntu VM, and we want to attach a network interface to it. And what we can do, okay, of course, if we don't have the MCP server, we need to list the template, okay, and we need to find the template that we want, okay. Then we need to, for example, one VNet list, okay, and we need to know, okay, this is the ID of the service network and so on. But what we can do is just as something like, for example, create an Ubuntu VM, name it, I don't know, like for example, Python webinar with one CPU and what else? And for example, and attach a NIC interface to it. Okay. Let's see what happens. In this case, he is thinking. Remember that based on the models that you are using, the thinking time could change, okay? Because of course there are models that are smarter, but they are also more easier, so they need more time. Another important thing that I want to underline is that he is able to understand that he needs to execute the MCP tools in a specific order. So he first lists the templates in order to understand if there is a template with Ubuntu. Then it lists the networks. Why? Because maybe we don't have any networks, okay? It's not granted that we have a network. So he's smart enough to understand that he needs to check if there is a network. And if there is one, what's the ID? And then, of course, he'll understand that once he knows the template, that the template exists, the network exists, and so he has all the information that he needs, in order to instantiate the VM, he can instantiate the VM. So the Ubuntu name Python webinar has been successfully created with one CPU. Okay, the VM ID is 830. Okay, let's see if we can trust him. Okay, let's see. Okay, 830, the name, okay. Let's see if there is the network interface attached. One VM show 30. Okay. Now, of course, we can also ask, could you please give me more info about this VM? Okay. Now, what it should do, okay, it's retrieving the VM status. I want to underline that he has the context of the conversation, because I asked him, could you please give me more info about this VM, but which VM? No, I didn't specify the ID, but he knows that I'm referring to the VM that has been previously instantiated. And of course, now it's giving us all this information. Repeat, I can be more specific, but this is not like the goal of this demo. I mean, then you can also play with it in order to get the information in the format that you prefer. Now that we have it, we can ask, for example, okay, please SSH into it and execute a command. Okay, that welcomes our viewers. Okay. This is just to show you that he can enter in the VMs, okay, SSH into the VM and execute command. Okay, now it's telling us that there is an issue. Okay, he's explaining us how to solve this issue. Okay. Okay, let's try again. Oh, sorry. One VM list. Okay, we have it. Okay. We can SSH into it. Good. Now let's try again to execute a command, and let's see if he's able to write a Python script that welcomes our viewers. Okay, let's see what happens here. Okay, sometimes happens that he does not understand very well the information. Okay. Okay, it's good that this is happening because related to what I was saying before, sometimes what happens is that this LLM can hallucinate, or they can just like enter in an infinite loop where they do things, then they redo the things again. Okay, so now let's see what happens. Okay, the Python script welcome viewer has been successfully created. Okay, let's see if we can trust him. Okay, let's SSH manually this time. Okay, ls. Okay, we have the script. Let's try to run it. Okay, so it works. So this was a simple example, but of course you can be more specific. You can give him more instruction. But the point here is to show how powerful it is. He's able to SSH into the virtual machine and execute commands. Okay, now we just have to write a simple script, but for example, it could be, hey, please install these dependencies, or install ngx and test this and test that, or execute this command. Okay. Okay, now there is another use case that I think it's important. Okay, we have a virtual machine here with ngx on it. Okay. What is the problem? The problem is that this ngx is not returning any web page. So when I do card, nothing happens. It say that the connection has been refused. So now let's open a new chat just to be sure that the context has been cleared, so that we are not polluting the LLM. And for example, we can do something like, okay, I have ngx installed on VM 81 in OpenNebula. We can use it in order to help us debugging the issue. Okay. Please fix it and be quick. But let's see what happens. Okay, so okay, it's checking the status. Okay. Okay, so ngx on the virtual machine with IP was initially not running. I have restarted the service and it is now active and running successfully. Let's see if this is true. Okay, as you can see, now the connection is not refused anymore. So what he did, maybe we can deep dive a bit in the command that it executed. He entered in the virtual machine, he ran the system status ngx, and he understood that ngx was not running, and it automatically restart the service. Okay, and as always, I want to underline that this was a multi-step workflow, right? So it first get the status of the VM. But why? Because maybe the problem was not on NGX itself. Maybe the VM was not running, okay? So it get the status, and then it execute the command. Okay, these are like just 3 demos. This was the final demo. And just to summarize a bit what we have done so far, in the first demo, I show you that it's very easy to get, for example, an overview of the cluster. You just need to ask for what you want, like, hey, please give me an overview of the virtual machine and so on. And it will do it without the need of touching the keyboard, apart of just writing the instruction. Then we also created a virtual machine with Ubuntu with one CPU. We have attached a network interface to it. We asked, please, to give us more information about this VM, and he was able to understand which VM I was referring to because he has a memory. And then we SSH into this new virtual machine, and we ask him to please create a Python script. Then in this final demo, we had a problem with NGX, okay, installed on one of our VM, and it automatically understood what the problem was, and it automatically fixed it for us without our intervention. So this show how powerful it is. It can also help us on debugging any sort of problems. So now that the demo is finished, okay, we can continue. Okay, so as I was saying before, one of the core principles at the base of the development of the MCP server was making it like open, no, to everyone. What does this mean? This means that this is an open source tool that can be adapted to your specific operational needs and internal workflow. You can find the link of the MCP server from OpenNebula here in this slide, and so that you can also check the wiki, how it install it, how to modify it, and so on. The server is built with modification in mind, so you can tailor the behavior of it. I can show you later how. You can also enforce your own policy. So imagine that, for example, you want that all the VMs that have been instantiated should follow a specific naming pattern, okay? You can write this in the instruction so that you don't need every time to, again, not to repeat, hey, please rename this VM or name the VM in this way. You can just change the markdown in the markdown instruction in the MCP server repository, and it will automatically do that for you. And of course, you don't need any deep expertise, okay? The MCP server has been developed in Python, but you don't need knowledge about Python in order to adapt the MCP server to your own use case. Why? Because in order to do it, we just need to change a few lines in some markdown text. So there is a very important file that I would say it's like the brain of the MCP server. Okay, this file is called MCP server_prompt.md. You can find it in the repository, and this file acts as the brain of the MCP server. If you edit this file, you will define the fundamental rules, okay, for decision making, security, execution, policy, and whatever that the MCP server should enforce. So this is just a screenshot. This is the current status now, the current version of this MCP server prompt file. But remember that you can change it, and this is just a text file, okay? You don't need any Python knowledge. So in this case, for example, let's study a bit this picture. Okay, in the first line, we are saying, no, okay, you are an AI agent that executes commands on OpenNebula, okay? And then we are also saying, for example, in the execution protocol, for example, we notice that typically it's very verbose. So we are enforcing the fact that it should not be verbose. We are saying you must be direct and concise. Avoid any other type of text. Avoid to output text that is not important. For example, another thing that we can enforce is that if, for example, the user asks for something, okay, you just something related to OpenNebula, the MCP server, okay, should be executed, okay? Why? Because sometimes there are some AI tool like Word that instead of using the MCP server, they are using their own agent, okay? But this is a problem because, of course, if you use the MCP server, the MCP server from OpenNebula, there are some security policies that we have been implemented, and this is very important. Then, for example, another security protocol that we have implemented is that when you execute when the MCP server, execute the MCP tool, that this case is called execute command, in order to run some commands, it should be very careful because there are commands that are very dangerous, okay? Like, for example, remove. Remove is the classic command that is very scary sometimes. So it should be very careful, and it should ask the user if it really wants to execute that command, if it can execute that command, okay? But here the point is that you can change this file and you can adapt to your use case. So now, in the next slide, for example, here is another example, no, of how you can enforce the policy at tool level, and you can really have a granular control over the MCP tool, the MCP server, and how it should be executed, okay? This is another file that you can change. Each tool has a description, right? So we have, for example, the execute command tool, we have the get VM status. Why this description is important? Because this description, together with the list of tools, is sent to the LLM, right? For example, Claude or ChatGPT. So if this description is very clear about how, when, and what is really important, what are the parameters of this tool, no? Then typically the MCP server will be more accurate. So the answer will be more accurate, faster, and so on. In this case, for example, we said, we put like some critical security check. So it should be able to recognize some patterns in order to reject the execution of these commands, like, for example, remove, as I said, or shut down, changing in the permission using ch mode, and so on, okay? But as always, you can change this. Now, in the next slide, we also put like an example of something like a bit more simple, but it's also very important. Here, you can use the tool description to enforce standards, such naming convention, resource limits, and so on. So imagine that you want to be able to instantiate some virtual machine, okay, but limiting the resources of this virtual machine. So if the user asks you, okay, please instantiate this virtual machine having 10 gigabytes of RAM, okay, if you said here, if you change the description, you say that this is not possible. So, for example, you can say, hey, never instantiate virtual machine with more than 10 gigabytes of RAM, okay, the MCP server will not do it, okay? So regardless of your use case, or regardless of the company, you can literally change this text, the tool description, and this will be in order to be aligned with your goals. Okay, now let's talk a bit about the project roadmap and the milestone. Okay, this is the first release of this MCP server. So of course there are a lot of things to improve, and we are gonna keep working on it and improving it. Of course, the first thing is that we need to be sure now, as much as possible, that the MCP server is safe to use, right? In order to do this, of course, we need to write a lot of tests. We need to improve our test suite, and we need to test how the MCP server work with different LLMs, right? Because ChatGPT is not the same as Gemini, and Gemini is not the same as Claude. What does this mean? This means that the answer will also be different given the same instruction, okay? And this, of course, is the first goal. Then, what needs to be improved? We know that the LLMs have a context, right? This context is useful in order to make the answer more accurate. Do you remember before I asked, hey, please give me more details about this VM without specifying the ID, and it was able to retrieve from the context, from the memory, this information about the ID and use it, right? In order to pass it as a parameter in the MCP tool. But what's the things? The things is that, unfortunately, that the context is not infinite, so it's limited. So in our next goals will be also to be able to understand how to only pass the minimum amount of information to the LLM in order to reach the goal that we want. Because of course, more information we pass, sooner the context will be filled, right? And this could be a problem because it increases the chance of the model to hallucinate, to create dangerous, to do dangerous things, okay? Because it's like polluting, the context, giving information that he does not need, so the model does not know which information is useful and which not. So this is another point where we need to improve, just minimize the data payload for the AI. And then of course, another important pillars of the our MCP server is we need to develop other tools in order to maximize the usage that the user can do, and enhance the ability of the MCP server to use all the features of OpenNebula. Now, for example, a feature that is missing is the possibility to browse, search, identify, and manage the entire life cycle of the appliance. So imagine that you don't have a specific appliance and you want to instantiate a VM. So what we want the MCP server be able to do is just browse for the appliance on the marketplace, download it, be able to understand that the download has been successfully instantiated, and so on. This currently is not possible, but this is one of the improvements that we want to make. Now, regarding the next milestone, as I said, I will be very quick here. We are gonna improve, of course, the test use, and we are gonna improve the amount. We are gonna improve the way that we currently use the process of sending data to this LLM in order to minimize the amount of information that we send to the LLM, in order first to improve the accuracy. And then another important thing, of course, that I forgot before to mention is the cost, right? Because more tokens you are passing to the LLM, to the MCP server, more expensive will be, right? Because the LLM should process more tokens, more words, and this has a cost, of course. And then a second milestone would be to enabling the MCP server to browse available appliance from the OpenNebula marketplace, okay, in order to also leverage this feature of OpenNebula. Okay. Now, of course, call to action here, we need your help because the repository is open to everyone. So how can you contribute on this? First of all, you can go on GitHub, search for for the repository, and there you can see there is a section called milestones where you can see what are the plans, the future plan for the development of the MCP server. So you can find the link here. And then I remember you that you can also join the forum, the MCP OpenNebula forum. There is a specific section for the MCP server. So if you have any sort of questions, I recommend you to join the community, discuss with other people, and ask questions, okay? And also, if you have any idea on how to improve the MCP server, please feel free to share it because we are paying a lot of attention to what the users are asking, okay? Okay. Now.
Okay, thanks, Daniele. Okay, so now we can go with some questions. Mm-hmm. Okay, let me check. Okay, there was a question about if it's possible to leverage the MCP server as a backend for self-service portal. Well, as Daniele showed, and also as I said before, practically the MCP server usually is local to your laptop. Let's say that you can use as a service, but in this case, it's something that you need to be careful about this because it's usually deployed as a local. That's the most secure thing. And I think, Daniele, most of the clients talk, let's say they run commands practically, and they don't use the streamer protocol. This is one thing. Clearly, if you have a particular API, now this is for your self-service portals, if you have a particular API, this MCP talks with OpenNebula directly. So it's implemented in such a way that it uses the command line interface practically. So if the command line interface is available and of OpenNebula, then yes, this is something that you can leverage as a way to use natural language instead of using. But clearly, our MCP server uses the OpenNebula command line interface. I hope this answers your questions. We already replied about the okay, for the sharing the presentation. We will see how to share this, but we can. And the last thing is about the availability. The link has been already put in the chat in YouTube. Also, Daniele showed it during the presentation. Yes, this is open. It works both for the community and the enterprise edition. So it just works with OpenNebula. So the most important thing you need to have locally in your laptop is the configuration of the OpenNebula command line interface. Then you can install from the repo, and then you can use the MCP server. Yeah, this is just the first release. As Daniele said, we are going to improve. If you would like to test and you discover any issue or some change that is needed, just please use the forum or also the GitHub repo that is open, so you can provide there any comment or open issue or any contribution. I don't know if there is any other question. I think no. Okay, so thanks everyone. I hope you enjoyed this webinar. Thanks, Daniele. And yeah, let's then meet for some other webinar next time. Okay.
Thanks, everyone.
Thank you. Bye.
Bye.